The following slides are a bunch of vocabulary words with examples and non-examples that I want you to go through and try to figure out what the definition would be for yourself. After the first 12 slides with the definitions that you're filling out on your paper, obviously this is quadratic functions, so try to figure out what a quadratic function is. There will be a slide with my definitions that you can either use to edit yours, clarify yours, or completely erase and start over yours. So click through, pause on each of the words, and see if you can come up with a definition based on the example and a non-example. I will go back and define all of them for you so that you know your quadratic vocabulary. So again, our quadratic function is defined as a linear function that has an x squared as the highest degree exponent. Most important part here being that x squared. That's super important that that is the biggest exponent that you have. That's what you guys noticed. The parabola is the U-shaped curve of a quadratic. So we had curves when we talked about exponentials for growth and decay, but these in particular are U-shaped curves. Vertex is either the highest or the lowest point, the turning point technically, either the bottom of a valley or the top of a mountain. Those are the vertex. The axis of symmetry is the invisible, because it's not actually drawn on there, but we're going to draw it, vertical, up and down, line that divides a parabola into two symmetrical pieces. Now you probably did not write this down because I don't think I had it defined on there, but when we're talking about the the zeros, what did you guys write as your definition for the zeros? The x-intercept is correct. Zeros is a fancy way to talk about the x-intercept. In fact, there's 4 fancy ways to talk about the x-intercept, and they spell out the word rocks. R-O-X-X. R-O-X-S. Wow, it's hard to enunciate those. And the O is actually a 0. The rocks stand for the roots, zeros, x-intercepts, and solutions that make up my zeros. I'm going to ask you probably at the door next time what rocks stands for. So these 4 things you're going to need to know what they are. In fact, you can look up on my wall over here, and I have all of them written there for you. It talks about how we find each of them, but that's more of an Algebra 2 concept. Not worried about how to find each of them. I'm worried that you know what each of them are. They're all the x-intercept. Just fancy words for them. Since the zeros are the x-intercept, how did you guys define the y-intercept? Did they get close to this? Where the graph crosses the y-axis? Yeah. Perfect. We've done that one a lot. Did anybody in this class remember what the other word for y-intercept we've used a lot? Initial value. Initial value. I don't have that one written on there, but if you want to write down that this is also the initial value, that's great, because that's also correct. Your y-intercept is always your initial value. The next 4 go together, so we're going to talk about the next 4 all together. We have a maximum point, a minimum point, a maximum value, and a minimum value. I heard someone notice the difference between the point and the value, but I want to make sure we got it. When we're talking about a maximum point, we're talking about the coordinate that is at the top of a hill. The greatest one. That's the biggest point, the tallest point, or the maximum point. Maximum means big, so it's going to be on the top of a hill or a mountain. Okay, and you definitely answer it as a coordinate, x, comma, y. Minimum point, did y'all say it's like the smallest point? The least, love it, the lowest. That's all means the minimum point. It's only going to be on the ones that look like valleys. The ones that actually look like U's and not upside down U's. Those are minimum points, x, comma, y. But when I'm talking about the value, I heard somebody say it. What did you notice was the difference between the point and the value? What were they interested in when they talked about the value? Look at your paper. I know you said it earlier. On the y-axis, when I'm talking about the values for the maximum and minimum, I'm talking about the y value where this happens. So we're going to say that's the maximum point, and maximum value is the height that it's at. Either the tallest or the smallest height makes the value for maximum value and minimum value. The y value or the height, like it's tall or small. The two at the very bottom are positive a value and negative a value. When you have a positive a value, you have a happy parabola. What does this shape look like if you have a positive a value? A smiley face. Happy parabolas are positive. Now you're like, Miss Quigley, what are you talking about with an a value? Do y'all remember when we did factoring like last week and there was an a, a b, and a c? Mm-hmm. Where was the a?
At the beginning.
At the beginning, next to what term?
X squared.
Next to x squared, which means our x squared term is going to be positive. Whatever number or letter is in the very front with the squared term is going to be a positive number. That means you have a smiley, a happy parabola. If we have a negative a value, what does our parabola look like now? A sad parabola, but it goes down. It opens down, makes a frowning face, and instead of having a positive a value, it's going to be a negative a value. Same thing as the ABC from factoring, it's the first number. Opens up as a happy parabola, opens down as a sad parabola. Mr. Riley teaches next door, and if y'all see him in the hallway for the next month or two, probably till the end of the school year, he'll walk around and tell you what mood he's in by either making a happy parabola or a sad parabola. So you ever see him walking through the hallways like this? He's being a sad parabola. It's weird, but it's a thing. Okay? So if you see that happening, that's what's going on. The last two definitions here, we've actually talked about domain and range like 500,000 times. The domain is the x values. Dr. XY tells me that. The range is the y values. Delore the robot tells me that domain is from the left to the right and that range is from the bottom to the top. But there's only one option for any non-restricted parabola that we're going to have. It's very similar to all the rest of them. And what does this symbol mean?
All real
numbers.
All real numbers. So when we ask about the domain of a parabola, and we're not saying it has endpoints, like you don't physically see a dot that's opened or closed to end it. You know it goes on forever. All real numbers. The range has two options. If I have a happy parabola, do I have a maximum or a minimum? Look at my happy parabola. A minimum. I'm making a happy parabola, so it has a minimum. Would you say the whole graph is above the happy parabola or below? Above. So we're going to use the above symbol, which is greater than or equal to talk about the minimum value. That's this right here, greater than or equal to. And you want to use that minimum value, the y value, to talk about it. So you would say that the y's are all above whatever that value is. And if you have a sad parabola, like this purple one right here, a sad parabola, is your whole graph above or below the maximum?
Below.
Below. So you're going to use the below symbol, which is less than. Lower. Below. Cool. How close were a lot of your definitions that you wrote for yourself? Were they pretty close? Or they're better definitions for you to understand than probably what I wrote up here, right?
Yeah.
Great. I love it. Even if it's not exactly what I wrote, it's something that you understand and you made a conclusion, unless your conclusion was wrong, in which case fix it. Okay? Now, today is all about vocabulary. So we're going to go to the inside of this packet. We're going to label some parts of a quadratic and make sure we know where they all go. If you need to flip this closed to remember what they are, that's fine, because we just learned all this vocabulary. On the inside, we're going to label the following for a positive parabola, a positive x squared. Where would I label number 1 so that it's a part of this happy parabola?
It's a point.
At the bottom, at the curve, it is a point. Is it right here?
Mm-hmm.
Perfect. We're going to label a number 1 right there for vertex, because that's what it says it is. All right. Boom, we got our vertex. We know where the turning point is. Now we are asked to find the root. Now, your root was not a word we actually put on our paper. You wrote it in. What was another word for root? The x-intercept. How many x-intercepts are going to be here? 2. Very good. We got to label both of them here and here with the number 2, because those are both considered roots. Like where a tree hits the ground, starts its roots, it's, roots. Where do I also label the zeros?
Same place where we label the 2's.
Same place where we labeled the roots or 2. So next to 2, we're going to write 3 because that's also the zeros. But that point is also the, cool, that's 4. And it is also the solutions. The rocks words are ROXS or R0XS. Roots, zeros, x-intercepts, and solutions. Literally no matter which version I ask you, you're always looking here at the x-intercepts. Easy. It's just 4 words that mean the same thing. Cool. Does this have a maximum?
No.
No, so we're going to straight up cross that one off. It does not have a maximum. We can't answer that question because there's not a maximum. Does it have a minimum?
Yes.
Where's the minimum?
The vertex.
1.
Same where 1 is, it's where the vertex is. So that, not 8. Wow. Come on, Miss Quigley. 7. This is number 7 as well. This is the minimum. The axis of symmetry.
Need to draw it.
We do have to draw it in because it's invisible. And when things are invisible, we make them dashed. And we said it's vertical. Where should this line meet up with my parabola? With the vertex, absolutely, because that's right in the middle. And if this line cuts it in half by its middle, we're going to draw a dashed line through the middle. Now, question. This is number 8. It's a vertical line. So is this going to be a Hoy or a Vux line? Here's what I'm asking. Is it Hoy or Vux? It is Vux. So what kind of equation is this going to be? It's going to be x equals. Absolutely. Keep that in mind for later. We're going to need that. Let's see how we did and see if we can do this again. You are going to label the sad parabola down on the bottom of this paper. So take a second, pause, and label all the things on the sad parabola. All right, she's going to label it for us on the screen. Good luck. Oh, wait, I didn't push the right buttons. Okay. Will you please label all of the parts of this parabola? Here she goes.
Okay.
All right, what are you doing first?
I'm labeling the vertex.
Okay. Is she right, class? Yeah. Woohoo! All right, what are you labeling next?
The root.
Where are the roots?
Right there on the x-intercept. Maybe 2. 2.
Is she good?
Yeah.
Woohoo! Next.
And then 3.
You go right there,
Mm-hmm.
4 go right there.
Mm-hmm.
5.
Mm-hmm.
Yeah, your roots.
6, 2.
No.
Your roots, your x-intercepts, your zeros and solutions, all of the rocks words are all right there. All right, what's next? Maximum.
And then the maximum is where the vertex at.
Tied.
And then we don't have a minimum.
Cool, cross it out.
And then we gotta draw an axis of symmetry.
Sweet.
Period, poo.
Awesome. Y'all give a hand for Kayla for taking the initiative there and being brave. That was awesome. All right. So labeling is tight, right? We can label all day long. We know where these things go. But the way I'm going to ask you questions about this is not just to label them necessarily, but to tell me what they are. So the next 2 examples, we're going to practice that. This is pretty much exactly what your homework looks like. So if you get confused on your homework, go back to these examples. The very first example actually is a kind of not so cute graph. So if you would please take your highlighter right now, and I want you to highlight the x and y axis because they're kind of hard to see. And I think it really helps if we identify our x and y axis here, especially for this question because it looks kind of gross. And while you're at it, can you go ahead and do that for number 2? So go ahead and highlight the x and y axis for number 2 just while we're at it because I'll forget to say it later. That way we know where all of this stuff is. Perfect. We're going to do the first one together. You'll have the second one on your own because I need to tell you how to answer these questions. You can tell me where they are, but how do we actually answer these questions? Well, if I ask you for the vertex, where am I looking to write that? Like, where am I looking on this graph?
At the bottom.
At the bottom, at the turning point. Now, to talk about this, it's a coordinate. So I need to give you an x comma y to tell me where that vertex is. If I start at the origin, I always start at the origin. How do I get from the origin? -1, up 1. Absolutely. So that is my vertex. -1, 1. That's it. Boom, the vertex done.
Boom.
Easy. You just plot the point, you tell me where it is. The second thing really trips people up sometimes because there's two parts to an axis of symmetry. You guys told me earlier that this was going to be a Vux line, right? So what does the equation have to start with?
X.
X equals. If y'all do not write X equals, I will not give you points for it. It is not just a number, it's an equation. Now, what does X equal though?
-1.
Absolutely. If we drew our axis of symmetry in on here, didn't it cross through the quadratic parabola at the vertex and at -1? That's the equation of the line that cuts that in half. Don't tell me -1. -1 is just a random number. If it's an equation, a line, I need the X equals. Okay? If you need to write that note for yourself, maybe circle this part and say, don't forget this. That way you don't forget it. That might be helpful.
Also, if you look at your coordinates of your vertex, what does it say where you have X? Your X and Y coordinate.
At the beginning.
It's the same thing.
What do y'all notice here?
Oh, -1.
They're both -1. In the X position of the vertex, the axis of symmetry has an X there. Literally all tied together. It's going through that point, so it has to have that X value. That's a quick check for yourself to make sure that you have the right number. Okay, let's talk about the rocks words. I condensed it all into one question, but I'm asking you here, what are the roots, the zeros, the x-intercepts, and solutions? -3 and what?
1.
Okay, so here's -3 and here's 1. Is that where it crosses? Where does this graph cross on the x-axis? It doesn't. Does it ever cross down here?
No.
This does not have real solutions, real roots, real zeros, or real x-intercepts. I'm not going to teach you about the imaginary ones. I'm going to let your Algebra 2 teachers teach you about them. So we would just answer that there are none. Because in Algebra 1, we don't deal with the imaginary number system. So we're just going to say there are no rocks. No roots, no zeros, no x-intercepts, no solutions. Now this question, the next one, actually has two parts. I don't want you to just tell me the value. I want you to identify if it's a max or a min. So does this parabola have a maximum or a minimum?
A minimum.
A minimum. So we're going to circle the word minimum. Oop, that's a highlighter. Come on, Miss Quigley. Circle the word minimum, and we're going to tell you what that minimum value is. Now, Abby told us that it's the y value when we're doing value,
Which is negative.
which if I come up here and I look at the vertex, what is the y value? It's 1. The y value. Ooh, I wrote that on the wrong part. That's embarrassing. This one can just be a number. This is the number 1. Now, where's the y-intercept?
Where it crosses the y-axis.
Cool. Where does this one cross the y-axis?
2. Wait.
At 2, but this is a coordinate, so how do I write that as a coordinate?
2, 0.
0, 2. 2 zeros an x-intercept. 0, 2 is a y-intercept. All right. I'm crossing my fingers so we can do this one. Hopefully we have it memorized. What's the domain of a quadratic?
All real numbers.
Thank you. Let's hear it again. What's the domain of a quadratic? Should be. If we look on the left, it keeps going for forever. If we look on the right, it keeps going for forever. So it's infinity to infinity. That's all real numbers. Love it. Now the range is a little bit different. We know range is what letter?
Y.
Okay. And what's the minimum value here?
Greater. 1.
1. Now we just have to decide if the whole thing's above or below it.
Above.
It's a happy parabola.
Greater than or
So it's above.
So visually, it's literally above it. So the above symbol is the greater than or equal to. That's above.
No.
It's 0, 2.
Sorry, I'll pull it up for those you can see at the bottom. Okay. Again, if you need to make a note for yourself because you're going to get confused with the symbols, it might be super helpful for you to have this written down. If you're going to do this, you say above, and this one is below. Might be super helpful to have that written down for yourself when we're doing domain and range. That greater than or equal to is the above symbol, and less than or equal to is the below symbol. Got to have those memorized. That's helpful for right now.
Honestly, I want to answer the next one.
You are going to answer the next one. Let's see how we do if we answer this next one. You've got all of number 2 to answer. Take your time on the y-intercept. It's a little tricky. All right, I think enough of us are finished that we can look at this. What is the vertex for this parabola? Ooh, remember it's a coordinate.
3, 4.
3, comma 4. It's a coordinate that is this top piece, the turning point. What was the equation for the axis of symmetry?
X equals 3.
X equals 3. If you just told me 3, that's not right. I will count that wrong. It has to be an equation, or else you've just told me a number. I need an equation for the axis of symmetry. Are there any rocks?
Yes.
How many?
2.
2. Where are they?
1.
If we look right here, we've got it crossing the x-axis at 1 and 5. There's 2 ways you can write this answer. Technically, some of them you're supposed to answer certain ways, but if you just want to write 1 and 5, that works for me. Or you can write them as coordinates. 1, 0, 5, 0. But not 1, 5, because 1, 5 is not an x-intercept. So either pick one or the other. If you're interested in which should be which, I can tell you, but at this point, I do not care how you answer it. 1 and 5, or 1, 0, 5, 0. Both are appropriate. Is this a maximum or a minimum?
Maximum.
Maximum. Okay. What is that maximum value? 4. That's the maximum height that it gets to. That's as tall as it gets. Doesn't get any taller.
No.
What is the y-intercept?
4.
So we're coming in here and looking for where it crosses the y-axis. Does it cross exactly at 4?
No.
No, but if you kept this going, where would it cross?
5.
At -5. That's why I said it's a little tricky. I'm sorry. Bad graph again. But we know that this is going to cross at 0, -5. If you wrote -4, you're like, might as well. That's fine. I know you would pick the right one if I gave you a better
I
graph.
picked -5.
Perfect. Now, let's see if we can do this. Crossing my fingers. What is the domain of a quadratic? I'd go to sleep happy tonight. What is the range of this?
It'll be y
Y is less than 4.
4.
Y is less than 4.
Y is less than or equal to 4 because it's all below that maximum value. Maximums means that's the biggest, so the whole graph has to be below it. So it's going to be below 4. How do we feel? So here's what I gave you. I gave you this piece of paper that you're going to fold and you're going to put into your spiral. I also gave you this Quadratics Keywords. I'm not really going to go over this, but when we get to word problems, it's going to be very helpful to have this sheet because it translates each of the points that we talked about today into their real world things. So like if you look, it says the vertex is at the maximum height or how long it took to get to the maximum height. The y-intercept is the initial value, how high off the ground when it started. The zeros are where it lands if we're talking about projectile motion. So these are going to be very helpful tips for you to have when we start talking about word problems. It should also be glued into your spiral for later reference. Do I have any questions about the vocabulary for today? Nah? Okay, here's what we're going to do.